Let's get a full screen going here. I've got limited time to do this, so I'm just going to basically do mechanics. All right, sine of 5 pi over 6. I know I got a marker somewhere. Sine of 5 pi over 6 should be a half, and let's see why. 5 pi over 6 equals, we're getting a lot better in class. We got boom, 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 boom. So there's the 5. There's the perpendicular. There's negative root 3 over 2. There's positive 1/2. There's 1. And the sine function is opposite over hypotenuse. So there you go. Sine of 1/2. I think it's useful to, get one function, one period of the sine function, which is altitudes are increasing in the first 90, coming back to 0, going to -1 and back to 0. So there's one revolution, 2 pi comma 0. I'd like you to start to see one period of the sine function as often as possible so that you gain familiarity. Here's 180 degrees, right? Which is here, which is no height at that instant. Backing up a little bit, we're halfway. Does that look like, if I'm drawing properly, that might match up with 150 degrees? Right, because we got a 30-degree reference angle. So it took 150 degrees to get there, and the sine value is a half. Next problem. Cosine of 29 pi over 3. Well, 30 pi over 3 is 10 pi, so we're one less than that. So I think we're looking at a half again, but let's draw it out. All right, so here we are, XY axis. We got 3. I'm going to do dotted lines. 1, 2, 3, 4, 5, 6. Okay, so we're here because this is 30. Yeah, 30 pi over 3, right? That's 5 revolutions. And we're one shy of that. 29 pi over 3. We draw good drawings, get good answers. The radius is 1. So I hope if you know the radius is 1, that looks pretty good there, 1/2. All right, so the cosine of 29 pi over 3 also equal to a half. Little pattern there. Looks like when the sine function's going up, cosine function's going down. Yeah, I think that's got something to do with our Greek god Pythagoras. All right, so the next one, 49 to the -3/2. Maybe you can just do it in your head now. Okay, what's that operation? Well, there's 3 things I'm going to do. I can do 49 to the 1/2. I can do 49 to the -1. I can do 49 cubed. I do not want to do 49 times 49 times 49. I do not want to create the fraction 1 over 49. I think I will do 49 to the 1/2, which I hope you understand is the square root of 49 written differently. Machines work really good with numbers. Computers now can work with these symbols, but for the longest time, couldn't. So, square root of 49 is 7. So now I'm doing either 7 to the -1 or 7 to the 3. I think I'll go this route. 7 times 7 is 49. And so if I did 7 times 50, 350, I'm 1 7 shy of that, so 343. So this is 343. What I just did was 7 times 50 minus 1. I did that in my head, and that in my head. That was one way to do 7 times 7 times 7. All right, now this is gone, so now I have 343 to the -1. Okay, so 1 over 343. Breaking that up into its parts for anybody who's having trouble seeing it. All right, but you'll be seeing it on every test the rest of the term, because if you understand what you're looking at, it's a pretty quick problem. Next. X equals -3, y equals 5. Eventually, I want you to have a little work with vectors in this class before you see a vector later on in your career and you don't know what you're looking at. Now's the time to establish that skill. So we're starting that process, although you don't know where I'm taking you yet. So x equals -3, we'll call that -3 in the direction, and y is 5. Well, there's a y value of 5, and I guess I'm trying to find the what? The cosine of angle A. So this is angle A. That's angle A, all past 190, but this is the reference angle right here, so I'll call it R. Okay, but angle A, reference angle R, cosine requires the hypotenuse. Can we do it in our head? 25 units of area, 9 units of area. Oh, the two little ones add up to the big one in this case. So that's 25 and 9 is 34. So that's the square root of 34. Can we see -3 root 34 and then adjacent over hypotenuse becomes our answer. So the cosine of angle A in this case is equal to -3 over root 34. All right, next problem. Equation of the line, -4, 3. I don't think I have to talk about this too much. I think at this stage, it's day 4. Well, it's the 3rd day you've done it. Yes, it is 4th day you've done this now. And I think the 4th day is magical. So I'm just going to put these numbers in a table. I'm going to put a couple of numbers next to them, like 97, like 9. And I'm going to write y equals the change in y over the change in x times x plus 4 plus 3. And I'm hoping I see that, and I see that quickly and easily in class today. And if I do, then I know you learned something. All right, next. B log base B, which means B to the what? B to the 4 and 5. I guess this is just checking out your understanding of exponents, right? We're looking for an exponent. Well, what exponent makes that? A 20. I don't think there's much more I can say. No, 4 times 5. I'll do it right here is 20. What do you put on top of B to get B to the 20? I guess a 20. All right, hopefully we're doing a little better with that now too. Now I've got n cubed, I think, with my bad eyesight, n to the 5th. So log n to the 5th means n to the 5th to the what? Right? And I got a feeling it's not going to be the number 5. So the 5th root is undone with it. The 5th power is undone with the 5th root, but I'll develop this further here. All right. And what do we have? We got n to the 5 over n to the 7. All right, so I'll develop it. So let's just look at the parentheses. N to the 5 over n to the 7th, which is n to the 5 times n squared. N to the 5 goes into the n to the 5 once. And 1 over n squared can be written as n to the -2. All right, so going back to the original. N to the 5 to the what gets me n to the -2. That's the work I did up here. Well, I certainly don't want that 5, do I? No, I want to undo that operation. I want to undo this operation. I want a -2. That's the exponential activity that I need to work with what I've been given to get what I want. All right. Maybe there's a better way to say that. I don't know. All right, next, I'm over here. Graphing form. Y equals 2x squared. I still have to complete the square for you geometrically so you can see what these symbols represent in terms of how they were, from where it should use the term invented. I don't know. Anyway, we've been talking about the most important x value. This one's got shape up. I know that -10 is on the increasing side. So the equation of, I'll make a tangent line here. That tangent line is actually y equals 20x minus 10. Okay. And it takes on those linear characteristics right there, just for an instant. All right. So then the question is, what's the vertex, which is the most important thing, right? I mean, we know that that location is 0 minus 10. All right, put a 0 in, you can see the y-intercept. So I now know my x-intercept is negative. Now the question is, how do I get it? I said x-intercept, excuse me. X value of vertex, how do I get it? Minus b over 2a, that's what you're trying to remember. And so that x in this case is minus 20 over 2 times 2 is -5, and that certainly matches up with what we've been talking about so far. So right now, I have 2x -5, I write x plus 5 squared, because there's a minimum here. This is the minimum value, and now we need to find it. How do we find it? We got an easy way of finding it, because we got a formula here that tells me if I put this certain x value in, I get that y out, and I now have a certain x value. So -5, you square before you multiply, that's 50. -5, oh God, there's that coincidence again. That coincidence, and 50 minus 100 is -50, -10 appears to be -60. And how far is it from -60 to -10? 50 units. So if I went over 5 units, I should go up 25 units. But I didn't go up 25 units. I didn't go up 25 units. I went up 50 units from -60 to negative. That appears to be a doubling of the squaring process. Oh, I didn't finish it off. So that's what you're trying to kick back to me, and this is what you're trying to see, and we're doing it every day until mid-December. So the sooner you give it your consideration, the sooner you won't have to give it any more consideration down the road. I don't think I want to say that. Every single one of these calculations probably has more layers of understanding than we'll ever get to. But from a standpoint of just getting fundamentally sound, you're going to work a lot less hard if you put the effort in now. All right, where are we at? Quadratic, -4,3 to 5,100. Those numbers should be familiar to you because you just worked with them linearly. But now we're going to work quadratically. So I am going to square the change in x. -4 to 5 is 9 units. I'm going to get 81 units of numerical change in my portrait. 93. Okay, so 93 over 81, x plus 4 squared plus 3 gets the job done. That's the quadratic, whose vertex is -4,3. When I put a -4 in, I get 0 squared, and I defy anybody to get me a smaller number inside that square for area using real numbers. Can't be done. Because it can't be done, that's why mathematicians decided to make up something that can be done. It's not on your sheet yet, but it's going to be from now on. What gets -1? Well, 1 times 1 doesn't do it. -1 times -1 doesn't do it. By definition, this distance, and I'll write that distance over here, is the square root of -1. And some bright soul said, let's call that imaginary. Let's imagine that there is something that exists. I times I squared, -1. We can do a lot with that, and we will start to develop that theme starting on Monday. I think I'll introduce that because it's important. And then we'll start working with it. We'll see what we can do. All right, it's not there yet. 50 cosine 4x. Some of you got to this yesterday. -pi. And we want to find f of pi over 6, and this is f of x of this. We're trying to find f of, was it pi over 6? What did I just say? Pi over 6. So we're going to take pi over 6, and we're going to multiply it times 4. 4 pi over 6. That sure looks like 2 pi over 3 to me. So we got 50 cosine 2 pi over 3 minus pi. That pi's not divided by 3. Well, I guess I can multiply it by 3 and then divide it by 3. I guess that's okay now. So that's 50 cosine minus pi over 3. All right, so we go to our circle. Boom, there's the x, y axis. Pi over 3 in the backwards direction is here. Going this way, right? There's 2 sides to the sine function and cosine function. I mean, you know, there's positive and there's negative. So we're going back the other way. Back in time. So there's a half. Well, that's the cosine. It's good drawing. 50 times a half, 25. There's your answer right there. Right? All right. You can always replay that. Wasn't organizationally done all that well, but we talked about the major themes. Well, we're good. I think we're almost done here. Yeah, we're not too many more. 30, 60, 90 triangle, measurements 10. Then when you get good at this, you know the other two measurements without having to do any work. All right, so we got a 30, 60, 90. We'll put it on its side. We'll do 30 degrees here. I gotta make it smaller so this makes some sense to you. So here's everything captured here. So there's our 1/2. There's our √3/2, and there's our 1. Now let's pretend we're going out further. Notice the ratios don't change, but now it's 10. Well, what's the relationship here? That's half the hypotenuse, so this is half the hypotenuse. Okay. What's another way of writing √3/2? I could have said 1/2 times √3. Okay, so how do I get this longer side? I think it's going to be 5 times √3. Well, let's do a little Pythagorean theorem. What's the area that goes with a 10? 100. What's the area that goes with 5? 25. Okay, so this area here is 75, which means that the length is the square root of 75, which means we have square root of 25 times square root of 3, which is 5√3. Now let's get rid of the unit circle. 30, 60, 90. How do you get from one to the next? You look at the pattern. You're the one that has to memorize it now, or see it and understand it, so that if I give you another one, then you think I'll give you another one? Yeah, probably one on every single test the rest of the term, where I hide one of the numbers in the 30, 60, 90 and see if you can get me the ratios of the other two sides, or the lengths of the other two sides. And it pops up on your SATs quite often, this question, because the College Board wants to know, do you know your ratios? You have a good trig class? You should. And you probably got that out of geometry, whatever year you do geometry in. Should have been discussed there too. Log 4, okay, repeating some things now. Can you just do this one in your head? Can you look at that? Pause the video. Answer the question. Are you starting to see that? Just because you know, right? Again, 40 to the x equals 1/16. 16 is 4 squared. Now we're the same base. Where is the squaring taking place? In the denominator. And that's what that minus sign means. So 5x squared. Now we're going right back to, let's hope. Well, I know there's gaps. I'm seeing them in every class I teach now. So 5x squared minus 8x equals 0. How do you solve a quadratic like that? A rectangle like that? We're trying to find a rectangle whose area, these are area statements, whose area is 0. Question is, what are the sides of the rectangle? Well, we can write it as a product with the first rule of taking out what's common. 5x minus 8. All right, so x, what number gets rid of that altitude? Well, I hope you said 0. Because if you did, you've got 0 times 5 times 0 minus 8. You do the math. You tell me what you get. What's the other length? The other length is 5x minus 8. And now I've written this as length times width equals area. And if the area is 0, one of the dimensions has to disappear. What number makes that length disappear? I hope you said 5/8. So you want to look at this and say 1 is 0, 1 is 5/8. 8/5. Tired of you. Second video, getting up early. All right, so 5x minus 8 equals 0. 2 inverse operations. Subtraction becomes addition. Multiplication, division. I think I put that in your last video. At least I hope I did. If I didn't, I'll do it right now. Let's do those parentheses. Let's do 4x minus 1 times 3x plus 7 times 8x plus 9 times 9x minus 2 to the 5th power equals 0. And how many answers do we have? Lots. One of them, 1/4. Next one, -7/3. Next one, get rid of the 9, divide by 8. Next one, get rid of the -2 with a +2 and then divide by 9. Hopefully that little bit of practice speeds up that calculation for you. Because we'll be doing a lot of products, a lot of sums and differences in the products. All right, what do we got? Get two more problems. Solve 2 log base 3 x plus 1 equals 6. All right, so how do we do this? Well, that's the best way to do this. Well, I know solving equations is isolating an x. I think I can isolate that. The question is, what are the operations? Well, it looks like I have 3 operations. I got a little multiplication, I got a little finding the value of an exponent, and I got a little additional 1. I got 3 things I got to do. So now, this is a calculation. All right, I'm going to get numbers out of that, and I'm going to double them to get 6. Sure looks like that box has to be a 3. So it looks like I'm going to do division first. I'm going to divide by 2. And it gives me log base 3 of x plus 1 equals 2. And then we want to see if, hey, if I put in some numbers, do I know how to rearrange them? So what if I have log base 3 of 9 equal 2? Well, that actually hits the one that we need. So how about I do a base 5? Log base 5 of 25 equals 2. So how do I rearrange it? You know, what does 25 come from? It comes from 5 squared. Okay, I guess I got the inverse operation for logging is using the base. Finding the exponent, using the exponent. Well, that's the inverse. So we're going to use this exponent to get that quantity. We're going to use the exponent on top of the base. So we can see that x is equal to 8. All right, so I put an 8 in here. What's the exponent? Oh, I made a boo-boo here. 3. Oh, I wrote it 2. I meant to say 3. Yeah, I am tired, aren't I? All right, I'm not going to redo the video, so let me just do it out without talking to you, so I don't make that careless error. All right, so divide by 2. I'll write everything now because I butchered that. That equals 3. Excuse me from that doing that before. So now I have log base 3 of x plus. Tired. Now I have x plus 1. This 3 is going to become the base right there. 3 to the 3. So now I've got x equals 26. All right, so now we go back and check. Why it's good to check your work. 26 plus 1 is 27. What's the exponent you put on top? 3 to get a 27 to 3. 3 times 2 is 6. Whew, am I almost done? 2x plus 5y equals 40. Been at this since 5 o'clock. Writing worksheets and doing videos. 2x plus 5y equals 40. All right, so standard form, should be able to graph this. I'm doing a table, I want to do an XY axis. What do I know? I know if I cover up that x is 20. That's the x-intercept. 20 gets me 0. So table, if you let your y equal 0, you're solving for your x. If you let your x equal 0, you're solving for your y. 8, 0, 8. Right, and there we have it. And we have an infinite number of friendly values because what's the next value in the table? 40 minus 8, 60 minus 16. I can do the same thing here that I did with the tables we generated earlier. All right, I'm running out of gas here. Just gonna end the meeting, take a little break, get a coffee, wake up, and we'll see you in class. Okay, well, this is Friday morning. It's about 8:30. See you soon.